Hello class, welcome to a new video, and in this video I'm going to talk about future value annuity. And remember from last week that an annuity is a series of regular payments that is made either to an account or from an account. And we also studied that there are two kinds of annuities. The first one is what we call the present value annuity, which we studied 3 weeks ago or 2 weeks ago. And this week it's future value annuity that we're going to study. And also remember that in the present value of an annuity equation, the lump sum comes before the series of payments, and the lump sum is in the present. A very good example of that you have learned is a student loan, right? So a student loan is an example of a present value annuity. Now, on the other hand, if we say future value annuity, the equation in an annuity equation, the lump sum comes after the series of payments. So in other words, your lump sum is in the future. And we also mentioned that a very good example of that is a 401k or a similar retirement accounts. So in this video, I'm going to show you how to do the calculations for a future value annuity. All right, so the first thing that you need to understand is the formula for your lump sum, right? So we will refer to the future value annuity as FA, and the formula is R. And then you have here a set of bracket, and then your parentheses, 1 plus R over M. Your exponent is MT minus 1, and you would divide that by R divided by M. Now, as you can see, again, just like in present value annuity, it looks very complicated, but don't worry, I'll show you the step-by-step guide on how to do the calculations. The formula for the periodic payment, on the other hand, is FA times R divided by M, and you have 1 plus R over M to the power MT minus 1. And I always mention this whenever you watch my videos, that a formula does not make any sense if you do not understand what the variables or letters represent. So in this example, FA is the lump sum, R is your periodic payment, R is the rate, and it's always written in decimal form when you do your calculations. T is your time in years, and M is your compounding period. So by now you are familiar with these letters because you have used them in the previous unit. All right, so now let's have an example. You save $200 a month in an account yielding 6.25% compounded monthly. In question number 1, how much will be in the account after 25 years? So this, I hope it's very clear that we're talking about a future lump sum. In other words, how much money or how much lump sum will you receive after 25 years? So this is a future value annuity. And we mentioned in the previous slide that the formula to get the lump sum is this one right here. And as you can see, FA is what we need to solve. Your R, which I underlined, is $200. The rate is the 1 in percent, which is 6.25%. And if I were to write that in decimal form, that comes out to 0.0625. So remember, I mentioned this 6.25 divided by 100 to get the decimal equivalent. It's always divided by 100. And you want to save for 25 years, so that means your T is 25. And since you're contributing every month, that's going to be 12 for your letter M. And just like what we did in the previous 2 units, we always pre-calculate our MT, which will become our exponent, right? So here it says MT, right? We want that to be a single number. So 12 times 25, if you do it correctly, will mean 300 contributions. All right, so now all the letters I will replace by the numbers provided to me, and maybe this is the best time to pause this video and then write it down so you can understand how to set up your equation, and then let me show you how I did my calculations, and then maybe you can do it on your own, right? So as you can see, just like last unit, I did the numerator and the denominator separately, right? And as you can see here, I have a bracket again, just like last week, but my TI-84 does not allow me to do a bracket. And so what I'm going to do, as you can see here, I have two sets of parentheses. Anyway, the bigger parentheses would mean the bracket. The smaller parentheses would mean the parentheses in my equation. So it's pretty clear, right, if you do it step by step, right, that they are exactly the same. And once you feel confident that it is correct, you would press enter or equal sign, and that is the top part. The denominator will be 0.0625 divided by 12. I calculated that separately, and I have these numbers right here. And just like last week, I will not be doing rounding on each step, right? So as you can see here, when I did my division, I copied the entire thing, right? I did not do any rounding. I will do the rounding in the final step. So once I did the division, it came out to $144,054.81, right? So I will only do my rounding on the final step. So go ahead, pause this video, try it on your own, and hopefully you will get the same thing. All right, so I hope you did pause the video and you are able to come up with the same answer. So now we're ready to answer question number 2, right? Question number 2 says, how much interest will you earn for this investment? So just like last week, right, whenever you calculate the interest, you have to figure out how much is out of your pocket, right? So in this example, you will contribute $200 per month for the next 25 years, right? So that would mean I will take the 200, I will multiply that by 12 because there are 12 months in a year, and then I will multiply that by 25 because I plan to contribute for 25 years, right? So if I do the math correctly, it comes out to $60,000. Now, how much money will you get? You will receive $144,054.81. So obviously the difference between the two will be your interest. But this time, right, you will receive the interest, right? Last time when we did present value, the interest will go to the bank, right? So you're paying the interest. In the future value, you are receiving interest. So it's a positive thing this week. So now the interest will be the difference, right? So if you subtract those two numbers, you will get $84,054.81, right? So you more than doubled your investment because you only put in $60,000, but you will receive an interest of more than $80,000, as you can see here. So if I add those two numbers, you will receive this total right here, which is your future value. All right. So that will be your interest, right? So future value is a good thing, right? Something to be happy about because last time maybe it was a bit depressing to look at the interest that you have to pay, and it's a large amount, right? But this time you will receive the interest. All right, let's try another example. You want your retirement account to reach $1 million, right? So meaning you want your future lump sum to be 1 million. The question now is, how much must you deposit each month in an account paying 5% compounded monthly to reach this goal in 40 years? All right, so let's start with number 1. So it's very clear that we are looking for your periodic deposit or your contribution to the account, right? Because it's very clear here how much must you deposit each month, right? So those are your keywords. And we know that the periodic payment, right, is given by this formula. And based on what's given on the problem, your future value is $1 million. Or we are solving for that. That's what we want to know. Your interest is 5%. So in decimal form, that's 0.05. You want to contribute for 40 years, so T is 40, and since you're doing it every month, then your compounding period is 12. Right? So just like in the previous slide, you have an exponent again, which is MT, and you must pre-calculate that to avoid mistakes. So 12 times 40 is 480 contributions. So these numbers now will go into the formula. and you will get this one right here. And just like what I did in the previous slide, I will do the calculations, 3 steps. I calculate the top, I calculate the bottom, and then I will divide. So as you can see in my calculator, I did the 1 million times parentheses 0.05 divided by 12, and I got this number right here. On the bottom, again, you have a bracket there, and instead of a bracket, you would put 2 sets of parentheses, right? But it's very clear because at least in my TI-84, right? Because the bigger parentheses would represent the bracket. The smaller parentheses would indicate the parentheses, right? So I did the math, I input it again in my calculator and I got this. And finally, I will divide those two numbers and I came up with 655.299, right? So we will round it up to 30 cents, right? So I will need to save $655, right, and 33 cents per month in order to reach my retirement of $1 million. All right, so now how much interest will you earn for this investment? So question 2 is asking for the interest that you will receive. And note that from the previous example, you will contribute $655.30 per month for the next 40 years. And that means that your total contribution will be that amount, right? And there are 12 months in a year, so I will multiply it by 12. And I want to do that for the next 40 years, so I will also multiply that by 40 years. So again, just make sure to clear your calculator and all these numbers are typed correctly, because if you don't clear your calculator, you may end up with the wrong numbers, right? So anyway, if you do it correctly, it will say 314,544.00. So since you will receive $1 million at the end of 40 years, then the interest is the difference between the two. So your interest for investing will be $1 million, and you take away 314,544, and if you do it correctly on your calculator, that comes out to $685,456. So therefore, that will be your interest. So that's more than that's actually twice, right, the amount of your contribution. So because you contributed about $300,000, you will get an interest of more than $600,000. So that's a lot of money, and that's why they are, advising us to start early when it comes to retirement, because it's really not how much money you put in, although it matters. But what really matters is the span of time, right, that you are contributing. The more time you have, the more interest you will accumulate. All right, so I hope this has been educational for you. And if you have any questions, just make sure to reach out to me so I can assist you.